Hi, in this video I'm going to explore how magic squares are constructed. On the screen there's a 3 by 3 magic square. It has all the numbers 1 up to 9 arranged in such a way that the 3 rows, the 3 columns and the 2 main diagonals all add up to the same number. 8 and 1 and 6, 15. 3 and 5 and 7, 15. 4, 9 and 2, 15. 8, 3 and 4, 15. 1, 5 and 9, 15. 6, 7 and 2, 15. This leading diagonal 8, 5 and 2 adds up to 15. The other diagonal 4, 5 and 6 adds up to 15. So that's essentially what magic squares have. Their main feature is the fact that they have rows, columns and diagonals that add up to the same number. Now, looking at this, would like to see if there's any sort of method to the arrangement, doing this in order 1, 2, 3, 4, 5, 6, 7, 8, 9. The thing you may notice is that 4, 5 and 6, there's a row of 3 numbers in order going from bottom left to top right. So there's a movement up a diagonal to the right. 4, 5, 6. However, that doesn't work for a 1, 2, 3, for instance. That would imply that there was a 2 here, which is off the magic square. So 1, 2, 3 would have to go up there. There's a 3 there, which if that was the end of a row 1, 2, 3, it would look like that. 4, 5, 6, 7, 8, 9, we don't have a row of 3. That would involve an 8 being there and a 9 being up there. Or if this was the end of a 7, 8, 9, that would be a 8 and this would be a 7. A 2 sitting down there, what, a 1, 2, 3, that would involve a 1 there, a 2 there and a 3 there. And again we've gone off the square. With an 8 would be 7, 8, 9, for instance, 7, 8, 9. So that's not going to work, or is it? If we have a look at what I've done with the numbers moving outside the magic square, and imagine that there was another square over here, and surprise, surprise, look, there's an 8, there's a 3 sitting in there. Let's do another one up here. Nine, 2, that's sitting in the same place as this 9 and 2. There is a pattern emerging. 7, 2, that's that 7, 2, 8, 1 down here, and that 8, 1 corresponds to there. It's like we were sliding the original magic square over. In fact, making a tiling would be a good description of it. So what we could do then is make a copy of this original magic square, just slide it that way, slide it up there, slide it up. In fact, make the tiling fill the whole of this plane and see what sort of patterns we get from that. So let me proceed to do that. Let's move a copy up there. Let's move another copy in there. Another one here. Another one down here. And there's one, only 3 to go. This one here. And that one there. And the final one there. So all I've done is taken this original magic square and made copies of it so that we have in essence a tiling of the plane using this original magic square. And you can now see certain patterns emerging. For instance, there's the 1, 2, 3. 1, 2, 3. This whole column well, it's not a column, it's diagonal, involves 1, 2s and 3s, and then the 4, 5, 6 appears in this diagonal. 7, 8, 9, 7, 8, 9, 7, 8, 9, it repeats, and you see that pattern appearing there. 1, 2, 3 again in this diagonal, 4, 5, 6 in this, 7, 8, 9 in this, and then 1, 2, 3, 4, 5, 6, and so on. So there's a lot of regularity in this magic square. So let's see if we can now build up the magic square using this idea of other copies of the magic square. So basically this square, this square, this square, this one are all identical to this one. So the squares up here correspond to squares down here. Similar for this. Squares up here correspond to squares in the original magic square. So as soon as we move off the magic square in an attempt to find a regular way of building this up, as soon as we move off the magic square, we'll then move back onto it with the corresponding square. You'll see what I mean in a minute. So let's start with the number 1. And the movement we're going to make, this clue we got from the 4, 5, 6, is diagonal movement up to the right. Diagonal up to the right. So that's the movement that we're going to make. So let's start off in the magic square with number 1. We follow this movement, diagonal upright, and there's where I should put the 2. Now in this magic square it's not the original one, so I find the corresponding square in the original magic square. That's down here. So I'm arriving at this square, placing the 2. I continue diagonal upright to the 3. We've gone off the magic square. We hunt for this in the original magic square. It's there. So I've arrived at this square with a 3. So I'm continuing now. I would have to place the 4 in this square, but we already have a 1 in this square, so I'm blocked. So from there I cannot go up there. Where is the 4? It's immediately below. So if you're blocked, it would appear that we move down 1 square. So there's a movement diagonal upright, and if you're blocked, move down 1 square. So I was blocked 3, 4 I can't put in there, so I have to put it 1 down. Continue with our move diagonal upright. 5 would get put in there, 6 would get put in there, 7 would get put in there, which corresponds to here, but it's blocked. So I have to, instead of moving diagonally upright, I'm blocked, I move down 1 square, so that would reach the 7. I then continue diagonally up 1 square, that's gone off the original square. I find the corresponding square on the original one and put my 8 down. I continue with my diagonal movement upright. I put my 9 there. I've gone off the square. I find the corresponding square in the original magic square, so I've arrived up onto that square from the 8. So there's my 9. I keep going. Now, I know I've completed it, but I would have been blocked. I can't go up there, so I go down 1, and there I've reached 1 corresponding to this. So I've arrived at where I started with the 1, and that's my magic square completed. Now, let's see if it's possible to do this without all this. Now, you should stop the video, draw a 3x3 magic square, and see if you can reconstruct this using diagonal upright. If you're blocked, move down 1 square. So stop the video, draw a 3x3 blank grid, see if you can construct that. Okay, I'm going to try that then. I know that the 1 starts off in the middle top square. The movement's 1 square diagonally up to the right, 2 would appear there, off the square, that corresponds to here, 3 over here corresponds to here. I'm stuck, I move down 1 square, 4, 5, 6, off the square, which corresponds to there, and I would be stuck. So instead of going up the way, I go down 1 square. 7, 8 corresponds to this. 9 corresponds to this. I'm stuck. I go down 1 square, which corresponds to that. I'm finished. I've reached where I started. So that's my 3x3 magic square. Let's move on now to a 5x5 magic square, and I've got one here, and see if the method that we developed works for this one. So for this 5x5, there's our 1 moving up diagonally to the right corresponds to this. Let me put copies of this as we did for the other one. So there's our tiling of the plane with the original magic square. And presumably, if this works, I've got the colours wrong there. Let me move that there. It's easier to see when you have a checkered pattern of colours. That's the original magic square. We've got a 1, 2, 3, 4, 5, 1. So this is 1, 2, 3, 4, 5. Here's a 6, 7, 8, 9, 10 blocked and so on. We've got 11, 12, 13, 14, 15 blocked. We've got 16, 17, 18, 19, 20 blocked here, and then 21, 22, 23, 24, 25. So the same diagonal patterns are appearing here. So let's work our way through this one. Incidentally, the row totals, all these 5 rows add up to 65, the 5 columns add up to 65, and the 2 main diagonals, this one and this one, each add up to 65. Anyway, let's start 1 in the middle, 2 off the original square, that corresponds to this 2 down here. We keep the movement diagonally up 1 square to the right. 3, 4 we've moved off the square corresponding to this. 5, now we're blocked, so instead of going up diagonally 1 to the right, we go down 1. 6, 7, 8 off the square corresponds to this. 9, 10, that's off the square, corresponds to this. We've banged into the 6, so we need to move down 1. It's 11, 12, 13, 14, 15. Banged into the 11, we're blocked, so we go down 16, off the square. 17, that corresponds to this. 18, that's off the square, corresponds to this. 19, 20, we've banged into the 16, blocked, so down 1. 21, 22, 23 is off the square, corresponds to this. 24, 25's off the square, that corresponds to this one. We've banged into the 21, 25, we need to go down 1, that corresponds to this. We've reached the starting place again, we've finished. Now, very much recommend what you do is to stop the video, draw a blank 5x5 grid, start with the 1, see if you can reconstruct this, and then check you've got it right by adding up all the rows, the columns and the diagonals. It'll do your mental arithmetic a world of good. So how did you get on? Let's see if I can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and we're back to where we started. So there was no running commentary about what I was doing, but if you've done it for yourself, you were successful, you would understand perfectly well what I was doing. Now, this is not, remember I said a 3 by 3 magic square. There was basically only one possible 3 by 3 magic square using the numbers 1 up to 9. That's not true for 5 by 5 magic squares using 1 up to 25. And I'll now show you a different magic square, and you might be quite surprised about how the methods that we've built up can be applied also to the other different 5 by 5 magic squares. So here's another 5 by 5 magic square, and as you can see, it's certainly not a diagonal upward to the right diagonal move that we're making. In fact, the 2 is a long way away from that 1, and this 3 and this 4 and 5, they seem to be this time scattered. There's certainly not a regular pattern appearing like we had before with consecutive numbers appearing up the central diagonal. They do seem to be scattered all over the place. So let's try and do the repeat pattern trick that we did before, where we take a tiling of this magic square on the plane and see what we can see in the patterns. So there's the original square in the middle, and they add up. That's 20, that's 39, 40, 57, 65. All the rows add up to 65, all the columns add up to 65, and the 2 main diagonals add up to 65. So how are the numbers spaced? Let's start at 1. There's 2. There's 3. There's 4. So there is a regularity, 5. Now the 6 there is blocked in effect, and look, the 6 appears again 1 square below the 5. 7, 8, 9, 10, there's 10. 6 blocks it, down 1, 11, 12, 13, 14, which is there, 15, blocked, down 1, and so on. So it would appear that if you play chess, the chess move along 2 squares and 1 to the left, in this case, 1 up in this case, so 2 to the right, 1 up is the move that's made. So the first move we had made, the movement rule, was up diagonally to the right. This movement rule is now a chess knight's move. 2 squares to the right, 1 up. 2 squares to the right, 1 up. But the blocking rule seems to be, there's 5 blocked by the 1. The blocking rule again seems to be 1 down. So given that information, stop the video, draw a 5 by 5 grid, start with 1. This time use a knight's move, 2 squares to the right, 1 up. When you're blocked, move 1 square down and continue that pattern. See if you can construct this magic square. So how did you get on with that? I'm going to try it here and you follow what I'm doing. This time I'll make no commentary at all. See if you can follow what I'm doing. And I'm back to where I started. How did you get on? Did you manage that? This is 5x5 magic square. The magic total 65 in all rows. It has a different movement row, 2 squares to the right and 1 up, not the diagonally up to the right move as we had before. But the blocking move was identical, 1 down.